All right, we're back with another day of 10.4, day 2. Here are the answers for day 1. Okay, for day 2, a polygon is an inscribed polygon if all of its vertices lie in the circle. Right, the circle that contains the vertices is the circumscribed circle. We've kind of seen that vocab word before. Here's a couple of examples. We have an inscribed triangle and we have an inscribed quadrilateral. And there's a couple of theorems that go with this. First is this one right here. No, this is 10.4. We'll get to that in just a second. How about 10.9? Okay, so if we inscribe a triangle, okay, in a circle, and I make sure that one of the sides is a diameter. So if this side here is going to be the diameter, no matter how I move this, if it is so here's not the diameter, but if I make it the diameter, one of the sides, what you notice is that this angle right here becomes a right angle. And the reason for that is because this arc here, this intercepted arc, would be 180 degrees, which would make that 90 degrees. And that is the idea behind theorem 10.9. Okay, so it says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. And then conversely, if one side is the diameter, then the triangle is a right triangle. And here's a wonderful word problem that you guys would probably use all the time in your daily lives. Your camera has a 90-degree field of vision, and you want to photograph the front of a statue. You move to a spot where the statue is the only thing captured in your picture as shown. Okay, you want to change your position. Where else can you stand so the statue is framed perfectly in this way? Well, anywhere on this circle here. So I'm going to draw a circle. Let's see. Okay, there we go. All right, so if I move anywhere, say, I'm going to use my smartboard here on this arc here, then this here will be 90 degrees going from there to there. Or if I stand over here, this angle here will be 90 degrees. So that'll keep that 90-degree viewing window that my camera has. So, like again, this is a pretty far-fetched example. All right, and then here's 10.10. This one is dealing with a quadrilateral. So now we're going to inscribe a quadrilateral in the circle. And we're going to notice something here. So the opposite angles here, I set this up 85, 95, 78, 102. Hopefully you recognize that those are supplementary there. And no matter how I move these angles here, okay, 85, 95, those stay the same. 95.98, 94.02. I can move these here, 73.22, 106.78. No matter how I move these angles here, or these vertice points, the opposite sides are always going to be supplementary. Is that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So finding the values for each variable is pretty straightforward stuff here. We're just going to do some algebra. Okay, so 68 and y have to be supplementary, so that means that y has to be 112. 82 and x have to be supplementary, so that makes that 98. And then here, c plus 2c minus 6 have to add 180. You can solve that for c. And then 8x plus 10x have to add up to be 180. You can solve that for x. So that is the other theorem for this section. And that's it. So thank you guys for tuning in to day 2. And again, I'll see you in class.